Welcome to the Journey Shake Hand. Well, I am pretty excited today. We're starting a new quarter and we're going to learn how to balance redox reactions in a basic solution. So please do the 2 warm-up questions to the best of your ability and we'll discuss them in a moment. Before we are learning how to do basic solution, we're revisiting the acidic solution. Well, we know that in acidic solution, we are only allowed to add hydrogen ions, water, and electrons in acidic solution. That is all we're allowed to add. However, the very first thing that we must do is figure out the oxidation numbers of all of the elements. Well, oxygen here is -2. There are 4 of them. That gives me a -8. Well, the whole permanganate polyatomic ion has a charge of -1. And therefore, in this case, manganese is +7 and oxygen was -2. Well, this is hydrogen peroxide, and peroxide is a polyatomic ion with a -2 charge. And therefore, the peroxide has a -2 charge. I'm going to set it equal to -2, and there are 2 oxygens, and therefore each oxygen has a charge of -1. Now we could also look at the whole compound H2O2, and hydrogen here is +1, and there are 2 of them giving me a +2. Plus 2x, and compounds are equal to 0, and therefore in this case it is also +1, and oxygen is -1. Manganese here obviously is +2. It's an ion. And oxygen is standing by itself and therefore it is 0. It is a diatomic molecule. Now we can see what has happened here is that the manganese has changed from +7 to +2. And therefore it has gained 5 electrons. And it was reduced. As you know, red is my abbreviation for reduced. Oxygen has gone from -1 to 0, and therefore it has lost 1 electron. And it was oxidized. Then I separate into my half reactions. Well, the MnO4 has gone to Mn +2. I need to add 5 electrons to balance the charges, and gainers go on the left. I need 4 waters to get those 4 oxygens, and therefore I'm going to have to add 8 hydrogen ions, and that half of the reaction is balanced. Then I have my hydrogen peroxide, and here notice there are 2 atoms of oxygen and not just 1. I lost 1 for each atom, but I have 2 atoms, and therefore I lost a total of 2 electrons. Now I have 2 oxygens here and 2 oxygens here, so they're balanced, so I only need to add the 2 hydrogen ions. And then that half reaction is balanced as well. Now before I can add them together, I have to multiply by the common multiple. Multiply by the common multiple. I need the electrons to be the same on both sides of the reactions. And therefore, the common multiple, the lowest common multiple between 5 and 2 is 10. Therefore, I'm going to multiply the top equation by 2 and the bottom one by 5. And then I write them again. And I have 16 hydrogen ions, 10 electrons, 2 permanganates, 2 manganese ions, and 8 waters. And then I have 5 hydrogen peroxides, and 5 oxygens, and 10 electrons, and 10 hydrogen ions. Then before I add them back together, I'm going to cancel a few things. The electrons must totally cancel, and then my 16 hydrogens will cancel these 10 hydrogens completely and leave me 6 hydrogens. And then I'm going to add them back together. And I get 6 hydrogen ions, 5 hydrogen peroxides, 2 permanganate ions, 2 manganese ions, 5 oxygens, and 8 waters. And that is in its lowest common multiple. And that's how you do number 1. In number 2, we are asked a variety of questions, and I put this in the format that you've seen on the worksheets so that we get used to doing that. Well, I can answer all of these questions by just looking at the basic information, and on the assessment, you will need to be able to do that. And my oxidizing agent contains the element reduced, and the element that was reduced is manganese, and therefore permanganate is the whole oxidizing agent. Then the element that is oxidized would be oxygen, and you could put an O or oxygen, the diatomic molecule, either one would be fine. The reducing agent is the whole compound, and that would be hydrogen peroxide. The amount of electrons that are transferred in the oxidation half would be 2 electrons, because we have 2 atoms. That would be 2 electrons. The electrons that are gained in the half reaction that is reduced would be 5 electrons. And then the total that are transferred in the complete reaction would be 10 electrons. And that's how you do number 2. And I'll be back in a moment and we will learn basic solutions. Here we go. I know you're excited about this. Well, in basic solution, we are only allowed to add these things: water, electrons, hydrogen ions, and hydroxide ions. Now, hydrogen ions are what make a solution acidic, when it has more hydrogen ions than hydroxide ions. And hydroxide ions make something basic. And you'll notice when we write water, we have both hydrogen and hydroxide ions in the water. However, we know that water is a non-electrolyte up to this point that what we have learned. But when we go into reactions, if we give the hydrogen ions, that would make it acidic. When we give hydroxide ions, it makes it basic. And we'll talk about that in our very ending topic 16. In the meantime, we'll just understand that hydrogen ions make something acidic and hydroxide ions make it basic. Now, I follow the same process very much until a very certain point, and then I'm going to change. And let's go through this together. The very first thing that we must do is find the oxidation number of all of the elements. And this is the problem that is given to you on the worksheet that has the basic solution problems for you. Well, we know that oxygen here is -2. There are 7 of them. That gives me a -14. Well, there are 2 chromiums, and this polyatomic ion has an overall charge of -2. And therefore, chromium in this case is +6, and oxygen was -2. And here we know that iodine is -1, and chromium is +3, and iodine here is 0. And then I do very similarly as I would in acidic solution. I see that the chromium has changed from +6 to +3, and therefore it has gained 3 electrons. It has been reduced. The iodine has gone from -1 to 0. Therefore, it lost 1 electron and was oxidized. Then I separate it into my half reactions, so we're still doing things exactly the same. So the iodine goes to iodine, the diatomic molecule, the iodide ion. Now I notice that there are 2 iodines here, and therefore I must have a coefficient. And so I didn't just lose 1 electron, I lost a total of 2 electrons here, and losers are produced. Then that one is balanced. And then I have the dichromate ion that goes to the chromium. And again, I must notice that I need 2 atoms of chromium, and I put a 2 in front. Now here I need 7 oxygens, and the only thing that has oxygen in it here that I'm allowed to add is water. And therefore I am going to add 7 waters. Well, as soon as I add the 7 waters, then I need 14 hydrogen ions. Now here comes the difference. However many hydrogens that I add, I must add an equal number of hydroxides to both sides of the equation. Therefore, I'm going to have 14 hydroxides here and 14 hydroxides here. Because as you know in math, whatever I do to one side of the equation, I must do to the other. And my hydrogens and my hydroxide become 14 waters. Well, 7 of these waters will cancel, with 7 here leaving me 7 waters. Now, before I can add them back together, and oh, I forgot those electrons, didn't I? I gained not just 3, but I gained 6 electrons. So I must have 6 electrons here as well. Ooh, electrons are negative. Now, before I can add them together, I have to have the same number of electrons gained as there are lost. Well, the lowest common multiple between 6 and 2 is 6. And therefore, I'm going to multiply the top one by 3 to get my 6 electrons. And I will get 6 iodines, 6 iodide ions, 3 iodine molecules, and 6 electrons. And then I can add them back together. My electrons must totally cancel, always, 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 and nothing else will cancel, and then I add them back together. And therefore I have 7 waters, 6 iodide ions, dichromate ions, and I get 2 chromiums, 3 iodines, and 14 hydroxides. And then I double check to make sure that I have the lowest multiples of the coefficients, and I have a 3 here and a 2 here, and therefore that is the lowest common coefficient, and I cannot lower it anymore. And that would then be my final answer. So you see, it's not that much different. The big difference comes in when we are adding these hydrogens, that we must add an equal number of hydroxides to both sides of the equation. And then our waters are going to cancel and give us a net amount of waters. And then we always do, the electrons have to be the same, gained and lost. And then we add them back together. That wasn't so bad, was it? It's actually quite fun. The better you get at it, the more practice you have, the more you like it, and it's practicing those oxidation numbers. Well, thanks for being here. I'm so excited to be with you this quarter, and I can't wait to see you tomorrow. Bye.